Hey guys, welcome back to my channel. This is Sunjida Nova. Today I'm going to discuss how to find the performance parameters of a three-phase bridge rectifier with resistive load. Before started solving one mathematical problem, let me discuss about some important formulas. At first, in order to solve the three-phase bridge rectifier with resistive load, we have to know the average output voltage VDC equal 1.654 Vm, where Vm equal peak phase voltage, and number 2, the RMS output voltage VRMS equal 1.655 Vm. One more important thing, there is a phase relationship between voltage and current in a purely resistive circuit. In a purely resistive circuit, all circuit power is dissipated by the resistors, and most important thing is that voltage and current are in phase with each other. That means if we write the voltage equation VDC equal 1.654 Vm, then we can write IDC equal VDC divided by R. And from this equation VRMS equal to 1.655 Vm. From here we can easily find IRMS, cause as they are in phase, so we can write IRMS equal VRMS divided by R. Okay, let's solve one mathematical problem. Suppose we have one question like finding the performance parameters of a three-phase bridge rectifier. A three-phase bridge rectifier has a purely resistive load of R. Determine number 1, the efficiency, number 2, the form factor if, number 3, the ripple factor, and number 4, the peak inverse or reverse voltage of each diode. Given that the rectifier delivers IDC equals 60 ampere at an output voltage of VDC equal 280.7 volt and the source frequency is 60 Hz. At first we have to calculate the efficiency, and we know the efficiency eta equal to the output DC power divided by the output AC power. So we can write efficiency equal to PDC divided by PAC, where PDC equal the output DC power and PAC represents the output AC power. Again, we can write PDC equal to VDC into IDC. And in case of AC power, PAC equal VRMS into IRMS. And as I have discussed earlier that in a purely resistive circuit, all circuit power is dissipated by the resistor and voltage and current are in phase with each other. So we can write IDC equal VDC divided by R. In that case, our equation become VDC square divided by R. And in case of the output AC power, our equation becomes VRMS square divided by R, as we can write IRMS equal to VRMS divided by R. And we know there is a relation between VDC and Vm. We can write VDC equal 1.654 Vm, and in case of VRMS we can write VRMS equal 1.655 Vm. Now using these values we can write efficiency equal to VDC square by R divided by VRMS square by R. Now finally I can write efficiency equal VDC square divided by VRMS square. Now I am going to put these two values in this equation. Finally my equation becomes 1.654 Vm whole square divided by 1.655 Vm whole square. And finally I will get efficiency equal to 0.9987. Multiplying this value with 100, we can find efficiency equal to 99.87%. Now I'm going to calculate the form factor. We know form factor equal VRMS divided by VDC. And I have calculated earlier VRMS equal 1.655 Vm and VDC equal 1.654 Vm. Now from this equation, I can easily find the form factor. form factor equal 1.006, and after multiplying this value with 100, I will get the final result, that is 100.06%. Let's calculate the value of ripple factor. We know ripple factor equal to root over form factor square minus 1. From the previous calculation, I got form factor equal 1.006. So after putting this value in this equation, my ripple factor becomes 0.03464. After multiplying this value with 100, I will get the ripple factor equal 3.5%. And finally, I am going to calculate the peak inverse or reverse voltage of each diode. For solving this, I need one equation, and that is peak inverse voltage PIV equal √3 into Vm. But in our question paper, it was given that output voltage VDC equal 280.7 volt. But the peak phase voltage Vm is not mentioned here. But we know that there is a relation between VDC and Vm. We can write VDC equal 1.654 Vm. By using this equation, we can easily find the value of Vm, cause the VDC value has already given in our question paper. So we can write Vm equal 280.7 divided by 1.654. After calculating this value, we will get Vm equal 169.7 volt. Now, from this equation, we can see that PIV, that means peak inverse voltage, equal to √3 into Vm. Now we know the value of Vm, so after putting this value Vm in that equation, we will get peak inverse voltage equal √3 into 169.7. That means 293.9 volt. In order to solve three-phase bridge rectifier with resistive load, these two formulas are really very important. And one more important thing, you have to remember that in a purely resistive circuit, voltage and current are in phase. So from these two equations, you can easily find IDC and IRMS. That's all for today. Thumbs up and share with your friends if you enjoyed and find it helpful. It motivates me to make more easy tutorials for you guys. Please subscribe to my channel and turn the bell icon on so that you can get notification whenever I'll upload new tutorials. Thank you guys.